Hi, my name's Dennis Richardson. I'm the West Coast Manager of Codes for American Wood Council. I want to thank you for having us here to speak today. And I'm going to look for the remote right there. Got it. Got the time. All right. Great. Thank you. My background is I'm a civil engineer. I've been a building official for 17 years, worked in building departments for 25 years. Before that, everybody's talking about wood being cool at the conference. In fact, that's kind of our motto. And so I think there's a country song about that. I was a woodie before wood was cool. So I've been around a long time. Way back when I was designing glulam wood structural systems back in an office back in, I don't know, I think it was 1981-ish, around there. I'm kind of dating myself. So been around the block a few times. As a building official, I've worked a lot with people that are submitting alternate methods of construction, and also one of the things that I really enjoyed doing was being involved in the code development process. So I've back since, I think it was the 1997 UBC was the first time I got involved in the code development process. I've been involved since then. So I love my gig at American Wood Council. I get paid to do what used to be my hobby when I was a code official, and part of what I do is I teach classes. One of the classes I'm teaching is a lot of the same material we're looking at here. It's in Eugene, Oregon on Monday. It's an all-day class on fire resistant construction 101, and we go into a lot of the heavy timber, mass timber, and also some lightweight construction. But if you're interested in that class, I think there's room still in it. Oregon building officials are the folks that are putting that on. As I said, I've worked in a design office. I've worked checking plans. I've worked as a building official, so on and so forth, and really been involved in the code development for a number of years. At American Wood Council, what we do is we put together consensus standards, the National Design Specification, Special Design Provisions for Wind and Seismic, Wood Frame Construction Manual. Those are all of ours. We have consensus committees that vote and maintain these provisions. We also have 6 field office staff, and I'm one of them. I cover 9 western states, basically the West Coast, and all of the West Coast states, Nevada, Idaho, Wyoming, and Montana. How many of you are familiar with Cdp Access? This is probably not a big code official crowd, but Cdp Access is the new process that ICC is using. It's kind of the electronic submittal and voting on the code process. And so it's something we're all adjusting to in the code business, and it's allowed the process to, there's group A and there's group B, and they kind of overlap each other these days. They're working still a few rough edges out of the process, and so those of us in the code development business are kind of working a lot of overtime lately. What this presentation is about is mass timber and building in the building code, kind of the past, present, and the future, the type of construction, how that in the building code basically regulates the contribution of the structure as a fuel in the IBC. Alternate means, and that's basically the current path to taller mass timber buildings right now. And then also a forum for tall wood that's coming up. The ICC has voted on an ad hoc, and I'll talk a little bit more about that. But American Wood Council proposed to ICC that there should be an ad hoc on tall wood construction with the goal of creating code changes that are viable for the 2021 IBC cycle. And that was approved by the board of directors, and they're in the process of filling that committee, and they should be making announcements soon. We've all seen this or similar slides. This is an infill project in London, 9-story mixed use. We had a code change very similar to this in the last cycle. We almost got passed. In fact, it had more than a majority of votes, but it didn't pass because it needed 2/3 to pass. When you look at a project like this, and this kind of shows the process that we're going through in the code development process. I can do a performance design of a building, and I can consider a lot of things we'll talk about, and I can get that approved under alternate means. But if I'm going to do it right out of the book, it's probably going to be pretty conservative, and it's going to be pretty much all encapsulated, just as this building, when they started this over in London, they've got gypsum board pretty much covering everything. I'll talk a little bit more about that. I think the question is, in the future, if you start out with a building that's all gypsum board encapsulated, at some point, will the code allow taking some of that away, and how much can be taken away based on the type of fuel in there. We've all seen buildings that are examples of mass timber, And so the question comes up, what is mass timber in the building code? Well, mass timber is not defined in the building code, so it's kind of a wide open term at this point. Heavy timber is defined, and there's a number of provisions. We rewrote the heavy timber chapter and got that approved for the 2018 IBC with the idea that we'd be coming forward and needed kind of a strong basis, a reconsolidated basis of heavy timber to build upon. And whether they call it mass timber or what, it's hard to say. I mean, one of the things I think of when I think of mass timber is basically it's something that's as big as heavy timber, which is, you know, the minimum dimensions are in the code, and it also has a fire resistance rating. Whether that definition sticks or not, you know, that'll remain to be seen. But there is no definition of mass timber in the building code. These are the provisions that the American Wood Council was successful in getting the 2015 code, and basically a definition of cross-laminated timber, the PRG 320 reference for the product standard. And I had somebody that saw the definition in one of my classes, and they said, wait a minute, could this be then cross-laminated timber because it meets that definition? And the answer is no, because it doesn't meet some of the requirements for the laminations that are in PRG 320. So you've got to look at both the cross-laminated timber definition, and you've got to look at, you know, obviously you have to meet the standard. So that's CLT that we all know and love and what the laminations typically look like. It was approved in the 2015 building code for 2-hour exterior bearing walls of type 4 heavy timber construction buildings. And we've actually gotten this section modified to clarify the actual thickness of these exterior CLT walls need only be 4 inches, but they need to you know, meet either calculation or testing for 2 hours. So this has been revised in the 2018, and I'll give you that code change. So for floors, meeting heavy timber, 4 inches. For roofs, 3 inches. And CLT can be used in type 3 and 5 construction. This is because it's approved as a product standard in the code. And so it is any material permitted by this code. And both type 3 construction for interior building elements and type 5 for any building elements accepts any material permitted by this code. So CLT can be used, and the heavy timber minimum dimension requirements for type 4 construction don't necessarily apply for type 3 and type 5. So just a little tidbit. Sometimes it gets confusing. We've got a code change that tries to clarify this that was approved this cycle. Talking a little bit about the states, state of Oregon is well ahead of just about every other state. They've got a statewide alternate method that was approved January of 2015. It adopts all of these provisions I just went over, and it also adopts some seismic, the R factor, for example. So you can design a building and meet the state alternate method throughout the state of Oregon. I think the limitation on height is 85 feet. California, the 2016 California Building Code will go into effect on January 1, 2017, and that has all of the, you know, the 2015 IBC CLT provisions. One of the state agencies, the Department of State Architect that was looking at regulating it for schools, we're going to basically preclude that for a seismic system because you don't have the appropriate factors yet. But we talked to them, and they basically said, well, it would be acceptable if it's accepted as an alternate means. You might look at me and say, Dennis, why do you have this picture of a podium? And this is a light frame podium on top of a light frame building on top of a concrete podium. Why is this here for a mass timber presentation? Well, bear with me a little bit because, you know, it's not how you get there, but it's where you end up. And, you know, what if I told you that, well, can you build a similar 3-hour podium to the 3-hour concrete podium or the type 1A podium out of CLT? You'd say, well, really, I didn't know that. What if I told you you're only one alternate mean approval away from an 8 or 9 story, 85-foot tall, all wood apartment building, and basically there's already a code change that's been submitted. It wasn't approved. That kind of steps you through the alternate means. What if I told you the code already allows 65 foot of light frame shear walls as the upper part of a two-stage analysis in ASCE 7. So you could do your podium as the lower part of the two-stage analysis, the light frame as the upper part. And what if I told you the building code already allows, if I have a building frame system and I put light frame construction underneath that frame system, CLT could qualify as a frame system if I've got piers and the CLT framing. I could put in a light frame system, and I've already got an R value right in ASCE 7, and it's a very favorable R value for the upper 65 feet of this building. What if I told you National Science Foundation just granted a $400,000 study to look at this kind of hybrid system, not just for buildings that are 85 feet tall, but maybe 120 feet tall in the future. So there's a lot of research going on, but there's a lot that can be done right now. And basically all the steps I took you through to get to that 8 to 9 story residential apartment building that's completely built out of wood, there's like one alternate means approval, and there's already a code change that's been authored that you could basically use as your model. There's no clear way how to get through this. I mean, when you have a new material and there's new processes out there to get from point A to point B, there's a lot of different paths to get there. So this is just one of them. We're pointing this out because, like I said, you can end up with an 8 or 9 story building. The building on the left, that would be under the 2012 IBC, and usually they had more height and they put mezzanines in. And so in the 2015 IBC, you could basically utilize wood for the upper stories of an 8 or 9 story building. So what if I want to go taller than 85 feet? That's the current maximum allowed by the code. Alternate means is the current pathway for this type of construction for taller mass timber buildings. We're all familiar with this project, SOM, 42 stories. If somebody wanted to approve this, they'd need to approve it based on alternate means because the current code won't take you there. So to do that, you look at the intent of the code. There's a little bit different language in the IBC than there is in the Canadian code. You've got to look at the alternate means provisions. Most building officials are familiar. This is a short list of considerations that your fire protection engineer might consider in making that kind of design. Basically, the two things that are currently regulated in the code for tall wood is, for type 1A, it's either 3-hour bearing walls, columns, 2-hour floors. It's type 1B is 2-hour bearing walls and columns or 2-hour floors. So that's the fire resistance rating in table 601. The other part that's regulated by the type of material is the contribution of the structure to fuel. And that's regulated because type 1A or B can't have combustible construction. So how do you come up with an equivalency to that? And that's one of the challenges. What's the difference between fire resistance rating and the contribution? Well, we all know that wood chars, and here's some of the ways that we look at it. What if it's encapsulated? This is a test that we ran back prior to the hearings of the 2015 IBC, and it's a 5-layer CLT panel with 1 layer of 5/8" type X gyp on each side. It's an E119 time temperature curve. This went for over 3 hours, 3 hours and 6 minutes. So it burnt for a really long time, and yeah, there was some delamination on the inside once the gyp board burned off. That's the inside of the panel. This is a bearing wall assembly. I think it's like 75 or 85,000 pounds on this assembly. So there's a draft off the NIST site that talks about encapsulation, and I would point you towards that because they kind of coined these terms. They've got basically exposed CLT, we've got limited encapsulation. The one in the middle is very similar to our test that I just showed you with 1 layer on each side. So it initially provides resistance, but it will eventually burn through. And then there's complete encapsulation, that basically the encapsulation is thick enough that the fuel is designed to burn out before the wood engages. And it's suggested that those might be used for different types of buildings. This is a test we did of nail laminated timber. We filled it up with foam furnishings and lit it on fire. And we had a really good 2,200 degree fire coming out of here in about 5 minutes, or about 4 minutes. It flashed over. And we burn it all out, and it's got 2 layers of gypboard protecting the nail laminated or the CLT. This is what it looked like when we strip it off. So the nail laminated timber really didn't know there was much of a fire. There's a couple little chars. We had a couple bookcases filled up with old building codes, and they made like a little campfire. And you could have got in there and cooked your s'mores. It was perfect, and it sat there for a long time. So there's a little singe in each corner, but for the most part, this is the CLT version that we tested. And again, after we burn out the camp or the compartment and the little campfire there in the back. I don't think this was 3 hours. This was probably an hour or so after. So we've got a summary on our website. We utilize this. It's obviously got a really quick, hot temperature, 2,200 degrees right out the get-go. This is a continuum of wood fire resistance, and basically the ones that are highlighted in yellow are kind of the ones that are covered by a current type of construction, and to the right are some potential types of construction combinations. But again, I could either have 2-hour calculated or 1-hour protection plus 1-hour calculated. They both are 2-hour fire resistance rated, but they behave differently from a standpoint of contribution. So one of the challenges going forward in the building code will be how to quantify the contribution of the wood and how that affects the height and area. And that's probably one of the areas that research is needed. The good news, it's good news, bad news. More research is needed, as you've heard. The good news is, though, if you're looking to build like a podium and you're going to completely encapsulate it, you don't really have to worry about that because you're completely encapsulating it. And you're only doing that for your lower floors. I put together a little key of, these are code changes in the 2018 Group A process, and we've just got through that process. We haven't seen the final vote counts, but we've seen the preliminary results, so I've got them here. And I'm showing you a bunch of code changes. Some of them passed, some of them failed, and won't be in the 2018 code, but the reason I'm showing you the ones that didn't pass is you can go into the ICC or our website and you can see what the code change was, what the reasoning was, what the logic was. And so if people are thinking about alternate means, it's just kind of a group of ideas. This was a code change for a firewall. It didn't pass. This dealt with the flame spread and exits. It did pass. Basically, a 3-hour podium. We had different encapsulation based on the type of occupancy. That did not pass. One of the fire folks told me is like, the reason we're not considering this is because we don't like podiums, period, concrete podiums or CLT podiums, because they can allow an NFPA 13 sprinkler system to get up higher. So that's why they didn't vote for it. Nothing to do with the podium. Zipping through this, so this is some of the encapsulation details. This was for a 9-story, 100-foot tall Group R, similar to an existing code proposal. And we actually, on the public comment period, completely encapsulated this. We had 2 layers of chipboard, and it still didn't pass. It needed a 2/3 vote to pass, and we had more than a majority voting for this. So one of our goals with these code changes was to generate interest, and also to generate interest, as I mentioned earlier, with the IBC ad hoc committee, which was approved subsequently to this. So we think we were successful in that regard. With that code change, we could have also allowed a podium. That was part of it. Proposal for type 3 exterior walls, that didn't pass. SCL included in type 4, it did. This is a reorganization I put together of basically all of the heavy timber provisions. This passed, and this kind of serves as the basis going forward. And basically, this is editorial. There's no code substantive change. So, but it will be a lot easier to go forward with some of the provisions that we'll need in the future with this as kind of the basis. Okay, protected concealed spaces. This is important. The committee agreed with 2 out of 3 of our proposed changes and subsequently disapproved it. So you can read the notes, which ones they liked, which one they didn't, and gives you an idea if you're considering an alternate means for concealed spaces. This is for SCL and CLT exterior walls. It made it through the process, but it failed the vote. So we were a little unsure of why that happened. We haven't seen the final vote. And this is the one I mentioned earlier that fixes the CLT wall thickness in type 4. And in conclusion, basically this is kind of an overview of the ICC ad hoc, and basically the board is supposed to be finalizing that this week as we speak. This is Professor Dolan's base to his table last night. You should drop by and say hi to him. But this is crushing of wood from a 4-foot panel that's rocking with a you know, center tensioned. And, you know, imagine if you had this and you actually put some light frame walls in it to absorb a little energy, that dual system I was talking about. This is the website link for that National Science Foundation Award. And conclusion, here is our website. It's got my phone number and my email address. Thank you very much. Really appreciate it. Thanks.